this video lesson, we're going to talk about how you can calculate pH and pOH when the numbers aren't so simple. Before, when we talked about pH and pOH, it was easy to work with pHs and pOHs when they were even numbers or whole numbers, such as 3 or 6 or 9. We would know that we would just do 10 raised to the negative of whatever that was. But sometimes the numbers can be a little bit more difficult, and so we have to look at equations that will help us out. So in this video, we're going to look at the equations, and then we're going to do some practice problems. Let's go ahead and first look at hydrogen. Whenever you're dealing with an acid, know that you're dealing with hydrogen, such as hydrochloric acid, nitric acid, phosphoric acid, and so on. Any acid, as we have learned, contains hydrogen, and it's the hydrogen ions that make something acidic. Let's look at the first equation on the left. Notice in this equation, you're solving for pH. Suppose I give you a hydrogen concentration, and I ask you to tell me what the pH value is for that concentration. The formula that we would use is pH equals negative log of whatever your hydrogen concentration is. Now suppose I gave it to you the other way. Suppose I gave you the pH value, and I wanted to know what the concentration was. In that case, we would use the equation that's on the right. Hydrogen concentration is equal to 10 raised to the power of your negative pH. Notice that this is an exponent. So let's suppose your pH value was 6. How we would set that up is 10 raised to the negative 6. That is for hydrogen. Now notice for hydroxide, or our bases, it's the exact same setup, only now we're looking at hydroxide, because it's hydroxide that makes a solution basic. Once again, on the left, when you're asked to calculate pOH, you're going to take the negative log of your hydroxide concentration. And if you're asked to solve for your hydroxide concentration, you would take 10 raised to the negative pOH. Now please notice that the H and the pH and the OH and the pOH go together. What I mean by that is this. If you take the negative log of a hydrogen concentration, the answer that it's going to give you is a pH. But if you take the negative log of a hydroxide concentration, or a base, it's going to calculate for you a pOH. This may seem common sense, but you'll notice as we start working out examples that we need to make sure we're keeping track of this. If you are ever asked to go back and forth between a hydrogen concentration and a hydroxide concentration, we need to have a relationship. That relationship is listed below. pH and pOH are opposite scales that work hand in hand. They should always equal 14. So suppose I said you had a pH value of 3. If your pH value is 3, we know that added to the pOH, it must equal 14, and therefore my pOH is 11. This will be a handy tool when calculating pH and pOH. Before we get started into some examples, let's notice a pattern or a trend or a sequence of calculations. If you are given a hydrogen concentration, the only thing you can figure out from that point with the equations we've learned is a pH value. You would do that by taking the negative log. Now, from a pH value, you could always go backwards and calculate a hydrogen concentration, but you could always go forward as well and go to your pOH. This would be our calculation or equation that we used, in which we know the pH and the pOH have to equal 14. Now from the pOH value, you could go back and figure out your pH if it asked you that, but you could also figure out your hydroxide concentration. So notice what I've drawn. All I've drawn is I've drawn a sequence for the calculations that we've just learned. Once again, if you are given hydrogen, the only thing that you can calculate directly is your pH. If the problem asks you to calculate pOH given a hydrogen concentration, according to the sequence, we can't do that directly. We would first have to go from a hydrogen concentration to a pH, and then from a pH to a pOH, and so on and so forth. Use this sequence if it helps you. If it doesn't help you, then drop it. With our sequence and our equations, let's go ahead and calculate our first problem. All right, let's read the problem together. It says, what is the pH value of a solution that has a concentration of hydrogen of 0.0040 molar? What is the pOH? So we see in this problem that it's asking us two questions. It's asking us, first of all, what is the pH? And then secondly, what is the pOH? So as I analyze the problem, I write down that those are the two things that I'm solving for. Now let's write down what the problem's giving me. Notice that it's giving me a concentration, and it's giving me a concentration specifically of hydrogen. So I'm going to write that down. All right. The only thing that the problem has given me is hydrogen concentration. Looking back at my sequence that I just wrote, right now I'm at hydrogen. I am asked to solve for not only pH, but pOH. Well, the only thing I can solve directly right now is the pH. So let's go ahead and first solve that. Using my equations that I have just written down, I'm going to use the first one, the one where I'm solving for pH given a hydrogen concentration. So let's go ahead and take a look at how this would look. I'm going to use the equation pH equals negative log of my hydrogen concentration. Plugging in the values that I know I'm given the concentration for hydrogen, and that is 0.0040 molar. Now let's go ahead and punch this into our calculators. Depending on what calculator you have will depend on how you punch it in. If you have a graphing calculator or a newer scientific calculator, you can punch it in just as it's written. Right now, let's do that. Type in negative log 0.0040 and then hit equals. If you did that correctly, your pH value should come out to 2.4. Notice that it's unitless. However, if you have an older scientific calculator, you might need to punch it in as follows. Type in 0.0040, then hit the log button, then hit the negative sign. If you did that correctly, you should still come out to 2.4. Now at this point, we've only answered the first question. We've only solved for pH, and that's 2.4. But we also need to solve for pOH. At this point in the sequence, we are right here with the pH. We can now solve for pOH knowing that both of them together have to equal 14. So if I do 14 minus 2.4, my answer that I get is 11.6. Now since I only have two sig figs, I'm going to go ahead and round that to 12. And so my answers are 2.4 for my pH and 12 for my pOH. Let's go and give you some practice right now with calculating pH and pOH. Pause the video and work these out, then hit play to reveal the answers. All right, for the first one, we take negative log of 3.0 times 10 to the negative 6. The pH for that is 5.5. For the second one, we take the negative log of 0.0055, and we get our pH is 2.3. For the third one, we take negative log of 4.5 times 10 to the negative 9th. Our pH is 8.3. Now for the fourth and fifth one, notice that it's giving you hydroxide concentration, yet we're asked to solve for the pH. According to our sequence, we cannot go directly from a hydroxide concentration to a pH concentration. We have to first figure out our pOH and then figure out what pH would be. All right, so let's do that. I'm going to take negative log of 3.22 times 10 to the negative third. When I get that, I get an answer of 2.49. Notice the 2.49 is not the pH, but instead, this is my pOH, since I was given a hydroxide concentration. To figure out pH, you have to subtract that from 14. So 14 minus 2.49 gives me 11.5. Doing the same thing for the last one, we take negative log of 2.5 times 10 to the negative 10th. That gives me a pOH of 9.6, but let's subtract that from 14. When we do that, our answer is 4.4. This is practice finding pH and pOH. Now let's look at a concentration or a situation where we're having to find the concentration given a pH value. Notice the practice problem we're looking at now. It says, what are the concentrations of hydrogen for the following situation? We have a banana that has a pH of 5.6. Analyzing the problem, I have pH equals 5.6, and I'm asked to solve the hydrogen concentration. Since there is a direct link from pH and hydrogen according to my sequence, here to here, I can do that with one simple calculation. Looking at my calculations or equations before, the equation I'm going to use to solve for hydrogen concentration is going to be 10 raised to the negative pH. Plugging in the values that I know, I'm going to plug in 10 raised to, my pH is 5.6, so I'm going to raise that to negative 5.6. Now in our calculators, let's do that now. Punch in 10, hit the raise to button on your calculator, which either is the caret button or the y to the x button, and then type in negative 5.6. Your hydrogen concentration with correct significant figures should be 2.5 times 10 to the negative 6. Now you solved for a concentration, so make sure you put your unit. Concentration is in molarity. Let's go ahead and do these last examples here. Pause the video and work them out on your own, then hit play to reveal the answers. All right, our situation is, what are the concentrations of hydrogen and hydroxide in the following solutions? We have milk that has a pH of 6.5, lemon juice has a pH of 8.7, and ammonia has a pH of 11.9. Since I know I'm going to have to calculate not only hydrogen, but also hydroxide, right away I'm going to calculate my pOH for each one, since I know I'm going to have to do that eventually. We know we can do this real easy by just subtracting 14. For milk, we do 14 minus 6.5, which gives us a pOH of 7.5. Lemon juice, we're going to take 14 minus 2.7. That gives us a pOH of 11.6. And finally, for ammonia, we do 14 minus 11.9, and that gives us a 2.1. Now I'm ready to go. To do the hydrogen concentration, I'm going to do H plus is equal to 10 raised to my pH. My pH is 6.5, but make sure it's negative. By punching that in my calculator, I have 10 raised to negative 6.5. That gives me a concentration of hydrogen of 3.2 times 10 to the negative 7. Let's do the same thing, but now for our hydroxide. Hydroxide is going to be 10 raised to the negative pOH, which is negative 7.5. 10 raised to the negative 7.5 gives me a molarity of 3.2 times 10 to the negative 8th. Doing the exact same thing for the last two, let's go ahead and work that out. 10 raised to the negative 2.37 is going to give me a molarity for my hydrogen of 0.0043, and 10 raised to the negative 11.6 for my hydroxide is going to give me a molarity of 2.5 times 10 to the negative 12. Finally, let's look at the last one, ammonia. My hydrogen concentration is going to be 10 raised to the negative 11.9, which gives me a molarity of 1.26 times 10 to the negative 12. And for my hydroxide, I'll do 2 raised to the negative 2.1. That'll give me a molarity for my hydroxide of 0.00 0.79. This now concludes the video on calculating pH and pOH.